Hello again, everyone, and welcome back to Enterprise Linux Security, this time episode number 22. And as always, I'm here with Joao. How you doing?
I'm fine, Jay. As always, it's a pleasure being here with you. And 22 episodes? Well, that's a
time
lot.
really flies.
Yeah, time really does fly. And after some time, it's like we're almost out of January 2020 by now. Anyway, we're going to be looking at certificates today and what they are, how they are generated, where we use them, and the potential pitfalls that we can find ourselves in when we're dealing with certificates. Yep. So let's get right into it.
Let's do it.
Basically, a certificate is a concept that was created to authenticate public keys, meaning that the key that you receive from somebody has this piece of information attached that actually verifies and has some information regarding the source, and you can look at it and you can check that it's the person or the website that you intend to connect to. Okay.
Yep.
This is based in a chain of trust here. There is this group of entities or organizations which are called certification authorities that are implicitly trusted by operating system makers, by browsers, by other programs that use certificates. And basically, those are the ones that will either create certificates for other organizations to generate them other certificates. Sorry for the redundancy there. Or they will just be implicitly trusted whenever you find a certificate from them. Basically, a certificate is a piece of authentication. It's what gives you that little padlock when you connect to a website, for example, and you look at the address bar and you see that padlock. It means that the website that you're connecting to has a certificate, and that certificate is valid. And valid here means that it's within the life expectancy of the certificate, if can be called like that. It means that it's in the proper date where it's valid. And we'll get into the dates in a bit because that's very important. It has been changing over the past few years. And it also means that all of the certificate chain from one root certificate authority all the way down to that certificate, all of those intermediate certificates there are valid. All of them are checked whenever you do a connection that relies on certificates.
Yep. And we'll probably want to set some context around a couple of things to kind of set the foundation as well. You mentioned the padlock, which is absolutely the case. And I'm sure we'll talk about this again many times, probably. But I mean, the absence of a padlock is a big deal. If you're logging into your bank and the padlock is not there, or it shows like a red X or a line going across it, whatever your browser does, that means you absolutely should not continue to sign in to that site. You should completely stop right then and there. Now, there's also locally signed or self-signed certificates as well. And if anyone in the audience, and I'm sure many have, you set up like a app on your local network or inside your company. Let's just say it's a virtualization solution. Then you go to the admin console. If you haven't added your company's certificate to it, you won't see that padlock there either. But you know why at that point. You just set this up, and now you need to add a certificate to it. One thing you can do, and I don't like this personally, but I've seen some people do it, is that they'll actually add that certificate to the company's browsers, the locally signed one, meaning they didn't go outside and buy it. It didn't come from an outside certificate authority. It came from within that same company, and then they could use some kind of automation system, maybe group policy or whatever it is, to make that certificate be available in everyone's browsers. But that's still a locally signed or self-signed certificate. And then the ones you get from outside, those are, like you mentioned, signed from a certificate authority. And in my opinion, I don't think you'll disagree with that. That's always the goal. Self-signed, I mean, it works. It follows the protocol. I mean, it's every bit an actual certificate, but it's not recognized by a certificate authority, which is definitely better.
Yeah, it's definitely better. It actually depends on the use case. If for your own use case, you're only going to rely on internal websites, for example, that will never be accessible from the outside, that are not even DNS visible or resolvable outside of the organization, you might even have an issue trying to get that certificate, that official certificate in the first place, because the certification authority that you requested from will not be able to validate that domain name. Actually points back to you. It's not visible out there. So you'll have to rely on self-signed. What you can do in those situations is create your own internal certification authority. So you'll have this system inside of your network perimeter that's responsible for creating certificates for your internal systems. And this actually works pretty well. It's very easy to deploy a certification authority. It's nothing very overly special there. And the only thing you need to make sure is that all the machines in your network actually trust certificates that are emitted by the certification authority that you create. And as long as that's something that is in place through a group policy, for example, like you said, or through some other automation, then it will work, and it will work just fine, and the browser will show you the padlock as well. I don't know if, of course, you've probably already seen this, but all the Linux distributions have this package called the CA certificates. It's basically the package that has the certification authority certificates. It's how the distributions update that information. Yep. Some have some other automation mechanisms to pull those from, for example, Mozilla's root authorization that also keeps a list of those certificates. But most Linux distributions will have a package like CA certificates or equivalent that just contains a list of certificates. And whenever you're doing a certificate validation, you look at all the certificates in the chain until you find the root certificate, and if all of them pass the validation test, then you accept it. This is actually an important point, and it actually came up a few months back when Let's Encrypt had an issue with one of their certificates. I don't know if you recall that, but one of the certificates from Let's Encrypt actually expired, and it was part of the chain. So when that one expired, it caused issues all over the place, because certificates that were valid, that were still inside of their lifespan, for lack of a better wording, were actually being flagged as having issues on the browsers and not showing the padlock correctly. And it wasn't the actual certificates of the websites that you were connecting to or the services that you were using. It was actually one of the intermediate certificates that was expired. This was something that happened a few months back. I'm sure probably you've heard about that in the news. And it just shows how the whole chain has to be valid. And the root certificate will issue a certificate for another entity, and then that other entity will issue another one, and then until the entity that actually provides you with the official certificate. And all of them have to be valid whenever you want to establish a connection like this. And that's sometimes harder than it seems.
Yeah, and there's a lot of components at play here, and we'll talk about those components. The idea, and there's many different reasons why we have certificates, but we certainly don't want somebody in the middle intercepting our traffic.
Mm-hmm.
You know, we don't want to go to our bank, and then I keep using that example because it's a good one. You know, money is private. You don't want to let anyone into your bank account other than you. But if there's some kind of DNS poisoning or a certificate was added to your system that, you know, wasn't the real one, I mean, we got to make this secure, because this is how we prevent people from, you know, doing a man in the middle attack and intercepting this information and getting our information while you know, presenting to us a fake version of the actual site. We want to know that the site that we're connecting to and the site that the information is being transferred back and forth into and out of is actually a secure, original, legit, you know, site that's not made by, you know, someone, you know, just trying to do bad things. But we want to know that we're actually talking to the right person or, you know, the right company. And that's exactly why certificates are so important.
And it's actually why the whole system works. A certification authority or an entity providing certificates, it doesn't have to be one of the root ones. It only works, you can only trust the certificates that are issued by them if they follow a certain set of rules when they are emitting certificates. For example, if I go to one of them and say, okay, now give me a certificate for google.com, and they give me that certificate, it's great for me because I can now impersonate all of Google's services, and I can do man-in-the-middle attacks for Gmail and for all of that. And it to your browser, when you try to connect to them and you're going to my machine, it will still show as the padlock being there and everything being fine. The certificate is valid. It was issued by a trustworthy entity, and it says it's for google.com. So yeah, this is google.com now. So those entities that are providing the certificates, they actually have a pretty important role here. They need to make sure that when they are checking the data from the certificates that they are creating, they don't let things like this slip by. And it's one of the reasons why every now and then you see the browser revoking, say, an issuer from somewhere and removing it from the list of accepted certificates because they issued something that they shouldn't. And I used Google example deliberately. It happened to Google in 2013, I believe, where somebody that was actually tracked to an IP address in Iran, but that doesn't really matter here, managed to get 8 certificates for their services and also for Skype.com and for Live.com and all that by an issuer that did not check that information. And they issued the certificates and they were valid and they were active for, I don't know, 8 hours or something like that. And it was enough to see that there was some traffic on those on the websites that they were used. So yeah, bad certificates being issued is very rare. It shouldn't happen at all, but sometimes it does. And it's one of the reasons why something like a certificate revocation list existed previously. And now something like an online certification status protocol exists. That OCSP is the actual protocol that makes this type of validations possible. It's not just that your browser will check to see all the parameters of the certificates are valid. For example, if it's in the proper date, if it's actually mapping to the DNS that you're trying to connect to. It actually calls back to certification authorities and asks for their status for that particular certificate. And if they come back and say, oh, we revoked this yesterday or something like that, you might not have that update on your CA certificate file, but you'll get that information nonetheless, and the browser will flag it as improper. So you'll get some warning that you shouldn't connect to that place. And previous to OCSCP, there was the revocation lists, and the issue there was that it was something else that you had to update, and it had to be updated regularly to make sure that you had the list of revoked certificates. And after some time, it looked like a blockchain that had thousands of entries there of the revoked certificates. It was really hard to keep track of, and it was very annoying to keep updating that because you'd have to update the one on the operating system, and then you'd have to update the one on the browsers, and then you had to update the one on your email client because they didn't use the same ones. So yeah, it was pretty annoying. It was pretty difficult to keep track of that. Mm-hmm. And it's one of the ways that this whole certificate system deals with improper certificates here.
Yeah, that's a big deal. Obviously, it's a big deal. But if a certificate slips through, someone does end up getting a certificate that's signed by a trustworthy, or, you know, I should say previously trustworthy authority, that's a big deal because reputation is everything here. So a company goes into business to, you know, issue certificates, and then something like that happens, and we've seen this happen, they're not trusted again. I don't personally know of a situation where this happened and then they fixed it and they were trusted again, but then again, it might have happened. But I've seen situations where, you know, certificate authorities, something goes wrong and they're out, they're done, gone.
Symantec, for example.
I was pretty sure that was it. I did, yeah, because I remember something about that. I don't know how many years ago it was, and that was a big deal. Like, it was all over the news. I mean, this isn't the type of mistake that just flies under the radar because people are looking at this intensely. So if you're a certificate authority, you need to make sure you're doing the right things always. You have the right checks, the right protocols in place. You're you know, going through and checking things. And of course, there's tools to help with that. But I mean, the whole system is built on trust. If you can't trust the certificate authorities, then you may as well not even have certificates at all, because you can't trust them and anyone can make them. So like you were saying, there's systems in place to make sure that people are getting certificates for domains that they actually own. And if you haven't ever purchased a certificate, then what you'll notice the first time you do it is that you have to prove that you own that domain. You can't just say, hey, I own google.com or learnlinux.tv. Well, okay, you say you own it. Well, I need you to prove that. And there's several different methods in place for how people can prove that they own that domain, but they have to go through that process.
Yeah, and that's just for the most basic certificates, the one that you use on your websites. There are other types of certificates, for example, code signing, the ones that are used in executable files to prove that they haven't been tampered with. Yep. That's a different type of certificate. Actually, it's the same type of certificate, but with different flags when it was created. And those are both more expensive and harder to get because you'll have to show more information to the issuer for them to give you a certificate of that type. You'll have to probably show them some ID card. You'll have to show them some other proof that you have, say, the company that you're trying to sign as. And yeah, that company that is going to issue you the certificates are the ones responsible for checking all of that information that you provide them. They might call you back at the number that you give them when you sign in. They might try to check your information to see if the company is actually something that exists and was not just made up on the spot. And then there are even more difficult ones to get, like wildcard certificates that are very hard to come by. A wildcard certificate, it's something that reads like asterisk dot and then a domain. If you get one of those, it's valid for anything under that domain. So if you get asterisk.learnlinuxtv.com, you can certificate everything from server1.learnlinuxtv.com to, I don't know, .learnlinuxtv.com, for example. And the same certificate will work on all of those and for all of the services there. And those are really expensive if you can get them. Most entities will not provide you with wildcard certificates anymore.
Yeah,
and
it's
then,
hard to get, yeah.
Yeah. And then there are even worse ones with the ones that on the browser will not show just the padlock, but will actually show that green flag with the company name, for example, that banks use very much on their home banking applications. Those are extended validation certificates. They are both trickier to get because you'll have to provide a truckload of information to the company that's going to give you the certificate, and you'll have to pay through the nose to get one of those. They're the most expensive ones that you can get. They are also the ones that are supposed to have to impair more trust in whoever is using that website or that service, because you'll be able to see immediately that the company is called so-and-so and it's the one that you're connecting to and all that. And those are the ones that are really, really sought. But again, very, very expensive. For the most basic stuff, you're not going to get one of those.
Yeah, so that's that's a great point. I mean, so wildcard certs, I mean, to really illustrate the value of this, I mean, if you think about an average company, they could have, wiki.acme.com, right? They could have blog.acme.com and all kinds of different things that, they have .acme.com. And, if you think about it, certificates, I mean, just one certificate, they're a little pricey, but it's not that big of a deal to a company. Not really. I mean, whatever. I've seen them for as low as $100. I mean, the prices vary. But then when you think of it, like you have to buy a cert for every single subdomain, then that starts to really add up. But that wildcard cert is good for all of them, like you mentioned. So they're more expensive. It's not necessarily about saving money because you probably won't, depending on how many you have. But it is better for sure than manually renewing 10 different certs for the same domain. And keeping track of those can get really annoying for IT staff. And it's so easy to forget to renew one of them. And that's a big deal that people really need to watch. And there's, different companies do that well, and some great, some not. But that's kind of what it is. You either have the wildcard cert that's good for everything, or you have, if you have 20 subdomains and that one cert is good for all of them, or, you have 20 different certs.
Yeah,
so
there is one trick that sometimes is used. It's the subject alternate names, which is one of the fields in the certificate. You can actually get different names in there so that the same certificate can be used in every single one of the names that you add to that list. But there is a limit to that list, and it's trickier to look at that certificate. And if somebody tries to access the website that uses the certificate and inspects the certificate, it will show the whole list of other websites that are covered by it. You might not want that. But the point that you raised about the maintenance around this, it's pretty important. It's very easy to get 100, 200, 300 certificates going in your infrastructure without having too much running on it. Because every single service will ask you for one, every single server will ask you for one, and then you need to maintain all that. And this is compounded by a fact that, remember when I said we'd get back to the longevity of the certificates in a while back? It's because about 3 or 4 years ago, you used to be able to ask for certificates that would last you 3 years. Then it went down to 2, and now you can only ask for certificates up to 12 months. That's the maximum amount that any certification authority will provide you with. So that means that every 12 months you have to renew that certificate. When you have 2 or 3 or 4 or 500 certificates, you have to renew all of those every year, okay? And they'll expire whenever they expire. If you renew them too soon, some certification authorities will add the remaining time to the new one, but most won't. So you'll get another 12 months. So, yeah. And the real issue here is that, okay, we could use something like Let's Encrypt, which has these very nice scripts there that automatically renew them. But every single service has a different procedure to renewing the certificates. Some you'll have to put in a different directory, and other ones you have to add through the interface, and other ones you have to change the format to something else that application will read. And you can't have a single solution to update the certificates on all of them. So you will have to do some manual work around that. And it gets pretty labor intensive. It's pretty easy to mix something up and get the wrong certificate for the wrong server, and then something breaks. And it can break in pretty amazing ways. Some services will depend on other services. And if one of the certificates in the middle breaks, you won't see that error. You'll only see the first one say it can connect somewhere, and then you'll have to go dig through the logs and through everything to find out the actual error message there and find out that it was an expired certificate that was causing all of this. It gets very annoying very quickly.
It really does. I don't even have that many that I have to renew. I have, a small handful, and it still annoys me all the same. So the best case scenario that you could possibly have if you don't have a wildcard cert is that you just so happen to have come up with all the subdomains the same day, right? Like everything you're about to implement forever. You did it like on I don't know, December 4th. So now everything is like December 4th is the only time you have to worry about. But that's never the case, ever.
Yeah.
Like I don't think anybody ever, anywhere is that proactive. Nobody knows what they're going to implement before they implement it. So the way it works in reality, maybe December 4th, you came up with your blog, you set up your blog, and then maybe 3 or 4 months later, you stood up a wiki. So now you have that. They're going to renew different times because you created them different times. It's not easy to have your certs all expire at the same time. It's probably, I don't want to say impossible. Someone that's oppositional enough will say, I'll have I'm going 10 years from now, I'm going to have them all aligned because I'm going to keep on going a couple of days earlier if I can until one day everything is lined up. But no one's going to, come on, right?
Yeah.
It's just a pain. And if you think about it, like you could have 20 different certs or 100 of them, and like you were saying, they expire at different times. So throughout the year, as much as every single month, possibly you have something to renew. It gets really hard to manage. But one of the things that I recommend everyone do as a minimum, most companies have an alerting system. If your site is down, you could actually have a check that if the cert is fewer than, 30 days remaining until it needs to be renewed, you can have a warning. And if it gets to like 14 days or a week or whatever, you could have an alert that's flagged as critical. I make it a muscle memory every time I set up a site. I always set up a check that same day for the SSL, always, every single time. And they're all the same. They'll alert me when it gets, a little too close. So that way, if it's something I have to manually purchase to renew, or if it's a Let's Encrypt certificate that is supposed to automatically renew, but for whatever reason, the cron job doesn't run, it doesn't update, then I know about it. But that's you have to get into that habit. And you have to implement that. It's the least you can do, but there's a lot of work around renewing things for sure.
That was one of the things that broke when Let's Encrypt expired that certificate. Their automatic tools started to fail, so they could not update themselves. You had to go in there and do it manually when that happened. I would say most of the vendors, of the certificate vendors, will have this dashboard where you can actually see the certificates you have bought from them, and you can order that by expiration date, and that's pretty handy. So if you make a habit of checking that every week or every other week, you'll have a pretty good idea of the certificates that are coming up for renewal, and you'll probably be able to ask for the renewal directly from there, so you don't have to ask for a new request. You don't have to create a new request on the system. That's what I meant to say. And you'll be able to do that through their interface. So that's pretty handy, but it's still something that gets really labor intensive really quickly.
It does.
I'm thinking about things like the format where the certificate, in which the certificate is. There are several different formats there. Windows wants them in PFX files. Apache, for example, wants them in PAM, PAM. I don't know how you want to pronounce that. Tomcat has these certificates that can be in several different formats, actually, and you have to specify the format that you're passing in to the certificate when you're configuring something under Tomcat. And it's really annoying. I have a pet peeve around Tomcat. I really dislike the way that they handle certificates in Java, but I digress.
We can have a whole episode on Java and Tomcat and still have more to say.
Yeah, and it's none of it is going to be very, very good about it. But still, the thing is, the automatic renewal tools, they don't work with all of those different things. You'll have to manually adjust them. Let's Encrypt is, again, very good. They are by far the largest issuer of certificates around. By far, their automation tools are pretty handy, but they cover just a small set of actual systems that they support. Apache being one, Nginx being one, some other tools also being covered, but no single automation tool will cover all of them. You will have to manually adjust whatever you're using. In absence of that, you'll have to manually do that. And yeah, I actually went through that on my previous job. I actually went through the shrinkage of the certificate window, and having to renew certificates every single day, because every single day some of them would expire, was really annoying. And it was, at some point, it was starting to get a large chunk of my time just dedicated to that. And it will eat away from other things that you need to be doing, and you won't be, because you'll have to be renewing certificates. The thing is, when they fail, the service fails.
Right.
So you'll see error message. The users won't be able to log in. You'll see complaints from whoever is trying to access it. Oh, but the browser is warning me. Should I log in? Is something wrong with the website? Has it been hacked? You guys don't know what you're doing. And that type of comments. And all of it is just because the certificate expired. They're absolutely true. The comments are right. We don't know what we're doing, and that's why it expired. But still, it's a lot of work to be doing that manually. If, like you said, you can manage to get them all in the same day, that would be the best.
Yeah. If you are an enterprise that has that, literally, like you've done the work and you have everything lined up to the day, and you don't have a single cert that you have to renew outside of that, please let us know.
Yeah.
There's going to be a contact form on the site. I don't know when I'm going to have that implemented. But just let us know. But another thing that's challenging about certificates that I've run into, because I've done a lot of work with managed services providers, and there's a couple things I'll mention here. So one of them, and I especially hate this, when you have to have the same cert multiple times for the same site. So let's just walk through this, for example. You have a website, and in front of that, you have a load balancer.
Yeah.
And you need to put the cert in the load balancer, because that's exactly what the users are going to hit first. Now, you could have 10 different servers behind that, and it'll round robin the users to the individual servers to kind of keep the load balance. That's what a load balancer does. But then you have to have the cert on each one. Now, you can make an argument, which is an interesting debate, that you don't need to put the cert be after the load balancer because the traffic is encrypted through the load balancer, and there's no other way if those individual web servers themselves are not accessible to the internet. Only the load balancer is. But there's requirements, especially with I forgot which certification it was, where companies require this, like the cert needs to be at every hop throughout the whole thing, not just the load balancer. So then you find yourself when you renew the cert, you got to add it to the load balancer. There's a procedure there. If you have a hardware load balancer, software load balancer, there's a different way to get that cert in there. Then depending on what the web server software after the load balancer is, you're updating that too. And then if you have like a Java app on those, then you have another one because you have the Java certificate store, which is a whole nother story that I don't want to get into. Oh my God, the Java certificate store is just needlessly complex. But then it's like, if it wasn't bad enough that you're updating the cert once, you're updating it for one site. 2 to 3 times for that one site. That's just ridiculous. But it is the case sometimes.
It is a pretty good, compelling reason to actually have a certification authority in your premises just to create the certificates between the load balancer and the end nodes that are actually providing the service. And that was actually how I got around the issue, and I was doing exactly that as well. And yeah, it's self-signed, but like you said, you have to have it there because the traffic has to be encrypted between the load balancer and the end nodes for compliance reasons. But the certificate is trusted by your machines. They are only accessible inside of your network, so it's going to work either way. But it's one of the good reasons to have that certification authority in your premises.
Yep.
And it's interesting that you mentioned the hardware load balancers. One thing that is very important here to note is that certificates have this key size attached to it. And the key size is the number of bits. 2048, 4096, it keeps growing to make the attacking it harder. The thing is, whenever the key doubles in size, the actual work that has to be done on the hardware load balancer is multiplied by 4. And every time the key size changes, you end up having to throw away a lot of hardware load balancers because they're not able to keep up with the load anymore, because they're just not powerful enough to do that. And when it jumped from 1024 to 2048, actually a lot of good load balancers started showing up on eBay because they just couldn't keep up with that change.
Yeah, that's a big deal too. That keeps happening. If you have to replace that with something that supports the key size. And so one thing I want to mention too is, since I'm on the subject of managed services providers, it's kind of interesting that, when I was new to the industry versus when I got, seasoned, I should say, my mindset kind of changes, and, you find yourself like predicting all the things that your client might do wrong because you've seen it done wrong so many times. You've seen the same mistake. And the one, I would say the most egregious mistake is how the client transfers their cert to you. So let me just set up the example, right? So let's just say you're working for Acme, you're a managed services provider, and you have a client contact you. They have a blog, and they don't want to spend time maintaining that, keeping it running and managing uptime, because their people have better things to do. So they want to hire a managed service provider or a hosting provider to just take that off their internal server and put it out on their cloud or whatever, so that they are responsible for it. They could stop worrying about it. Now, that company is faced with a decision. They go and buy a cert and then send it to their MSP, have their MSP make the cert for them, or basically they need to have a cert. And most of the time I find that the company already has a cert, because their domain, it's not the first time they set up their domain. They have the domain, acme.com, but they might not have, or whatever their company name is, but then they have a cert for, maybe they want blog or whatever the domain is. Anyway, so usually what happens is the managed service provider would say, do you need us to get a certificate for you, or do you already have one, like a wildcard cert that you would like us to use? And I see this happen all the time. We have one. We already paid for a wildcard cert. We have that already. We'll get that over to you. And then, and I think you already know what I'm about to say, right? Because I could tell, like, people listening can't see the look on your face. I know what you're thinking. And then they what they do is they send you you as the IT person via email, their private and public key, and then I facepalm. At first, when I was first new to the MSP market, I would always feel like, well, they know better. I mean, right? I mean, they're not gonna. And they did what? They sent it by email. It got to the point where when I had a new client, I would literally have to have like a 5-minute or 10-minute conversation of all the things not to do with that cert. Don't send it to me by email. It has to be encrypted. It has to be secure, because the minute that they send in plain text unencrypted an email with a private and public key for the cert, guess what? You've invalidated that cert for everything that you used it on, and you need to go not only give me a different cert, you need to go through your sites and actually update those too, because now we can't trust it anymore. That's a huge problem, but a lot of people don't know that. So I definitely wanted to bring that up, because you should never send it via email. You have to have some kind of way to send it securely. Otherwise, you just broke that trust.
Yeah, and that's actually the issue with the wildcard certificates. You have to deploy them everywhere that you need them, and all it takes is for one of them to be hacked and the certificate is gone, and all the others have to be changed as well. It's the same certificate. So somebody with that certificate can impersonate any of your systems that was using it. And that's very dangerous.
It is. So, and to kind of bring this back around in context, when you go to buy a certificate, you, well, first of all, just to kind of walk through what the process generally looks like. You have a domain, whatever it is, and you want a cert for that domain. Maybe you don't have one yet, and today's the day you're about to go get that cert, because, you know, it's the right thing to do, and you probably should have done this before, but we're not going to go there. So you go and you buy the cert. You actually have a certificate signing request, a CSR, and you could correct me if I'm wrong on anything, because I know the general. I'm not like a certificate expert here, but I've been through the trenches on this. So you have the signing request where you fill out the fields, like what's your company name, email address, all that other stuff, and you submit that to your certificate authority, wherever you're buying your certificates from, and then they want you to prove that you own that domain. So it could be adding a text record to like your DNS, for that if you're in control of the DNS. It could be, I mean, there's different ways to validate that you own the domain. It could even be that they'll send an email to webmaster@yourdomain.com, and you have to be on the receiving end of that to prove that you have the domain. There's different ways. Anyway, once you prove that you own that domain, then what they'll provide you with is a private key and a certificate file. Sometimes it'll be like a full chain. We'll get into that in a minute, a CA file. And then you grab these files once you've purchased it and the certificate is signed, and you place them at the web server where the web server can access them to secure the connection, or your load balancer. And that's one reason why this could be a problem, among other reasons, because if the load balancer has a security vulnerability, and with hardware load balancers, this is very common, where guess what? They're not selling this model anymore. They're not going to give you a security update. So now, through this vulnerability, maybe someone theoretically could grab that private key, and now they have the private key. The certificate can't be trusted, so you have to actually make sure that's secure. But you have these different components of a certificate. You have the public key, which is public, and you have the private key, keyword private. They don't just put the word private on it just because they think that word sounds cool. They do it because it's private. Keep it private. Don't let anyone see it in plain text. Don't send it by email. Especially don't put that in GitHub when you do your Git push or whatever. Believe me, this stuff has happened, and you want to keep that safe. But I also wanted to mention that too, because there's different components of a certificate. It's not just one flat file, although it can be, but there's different components that go into that cert.
Yeah, and it can be used in multiple places. For example, when you have a code signing certificate, it's included in the build process for whatever you're compiling. It's part of the build process to pass it the certificate, and you have to pass it the private key. You have to pass it basically the private key, so that it can sign the file that can then be verified against the public part. It can be used in many different places, and you have to secure those locations. And that's why you shouldn't upload it to places like GitHub, for example. You should include it in the build process, but you should use their security tokens. I believe that's the name of the feature, where you don't want to have that directly there, but you can pass it in the build. I don't know if that's the actual name. If it's not, somebody will surely correct me in the comments.
Yeah.
It's used in many different places. It's used in many different software solutions, and it's different on everyone, like I said before. So there are different ways to secure it on each one, but you'll have to do some reading and learn how to properly deploy the certificate after you get it, so that you do it securely. For example, setting correct file permissions on the private key. It's not just copying it to the right location. You actually have it to only let it be readable by whoever is supposed to be reading it, specifically the web server process if it's being used in Apache, for example, and not just being read by worldwide in the system. That's something that you should actually look out for. Just practice good hygiene around the certificates. Don't let them be accessed by who doesn't need to actually look at them.
Exactly. And also know your process, because every app or web server or whatever it is that can be secured has a different way of updating that cert. Now, to build some context around this, if you buy your cert from a certificate authority, you always use the same one, then part of this process is always the same, because that place you're getting your certs from, they have the policy for renewing. So it's time to renew. Okay, you go on their website, you have a process you follow, you obtain the updated cert. But it's after that things change, because one app I use, for example, you can't replace the cert. What you have to do is you have to add a new one with a different name, and then you have to go and change the web console to point to that cert instead of the old one. You can't replace it, but you're adding a new one. Then you can point it to the new one. Then you can delete the old one. Another one might let you replace, right there on the spot. But anyway, there's going to be different things too. Like you might have to restart the web server, maybe do a reload or restart. So what this looks like in practice, especially if you're new to IT, is you go starting at a job and, the company has all these sites. Then what you'll probably find, if they do have, a wiki, which every company should have an internal wiki, that, okay, it's time to renew this particular app. Here's the process for this app. And then when this other site, app, subdomain, whatever it is, when that one expires, okay, this is the procedure for this. You have to put the cert in this location, these files, put them here. You have to make sure that this config file is pointing to them. The permissions are restricted in the right way. And then you have to restart a process. It might have to be done under a maintenance window, for example. And then that's one of the challenges here, is that every app that you use will have a different procedure for updating the cert. And what complicates this, and I've actually had a situation come up, I think it was with Okta, if I remember correctly, way back at another company I worked for. We updated the cert and tested it, and it was fine. The expiration year was the right years, a year from the day that we did it. Everything seems great. But then we had people saying, oh, why is it telling us that we can't trust the cert that is expired? Like, what do you mean? Not only did we replace it, we tested it. But come to find out, there's some kind of CDN in place, and they had a CDN issue to where, depending on which Okta server or whatever, and Okta is a single sign-on solution, you might be getting an older version of that cert because it hasn't propagated yet. So at first we're like, yeah, we clearly did something wrong here because many people are having a problem. Then come to find out, the team that I was working with, we did it right, but there was an issue at Okta side they had to fix. There's all these different challenges. And I don't say any of this to scare people away from certs. The reason why I'm bringing all this up is because I feel like it's better when you're in the industry if you know some of the things that could happen. So that way, if you do experience something, you might say, oh, yeah, those two guys on that podcast, they mentioned something about this, that I might run into this. It's just the way it is. That's just how it goes.
Another thing, actually, two things that I want to mention that I remember while we were talking about that example there. One that was very tricky to update was on a Windows machine, Windows Active Directory Federation Service is the single sign-on solution from Microsoft. And we had that on my previous place. And the thing is, when you want to change the certificate to a new one, you can't just remove the old one or the connections will break. You have to keep both of them active at the same time and then initiate this rollover process where they will get swapped. And then after some time, you can go in and remove the old one. It's not just something that you can get in there. Okay, this is the old one, remove it, add the new one, select it, and then there are more steps than that. And what is valid here is also valid for other applications. I remember, for example, Shibboleth, another authentication provider, this time on Linux, it also has this type of rollover in place. You have to have an old certificate in order not to break connections to other authentication servers. And then you add the new one, and then you let it simmer there for a few hours, and only then can you actually remove it. Another thing that I learned over the years is that some versions of Apache would want you to have the whole certificate chain on the same certificate file. Others were happy to have it on a separate file. But both of them would load, and both of them would report no errors when they started. But if you try to access the website on specific browser versions, ones would complain that they could not validate the certificate, and others would say everything was fine. And in the end, it turned out because the certificate file did not include all the intermediate certificates in it. And it was a pretty easy fix, but you had to know that this could happen to be able to spot the mistake and actually get in there and fix it. And this type of
whole chain, right? That's what it's called, if I remember correctly.
It's the whole certification chain. And now on most recent versions of Apache, it's actually a separate file. It's actually a CA file, a chain file that you add as well. And you don't even have to change that one if the certificates in there don't change when you renew a new one. But it didn't used to be like this.
Right.
So if you have a new application that you're setting up and it asks you for a certificate, do look at the documentation there. They will probably have this documented somewhere, and the process will be different for each application. If you have a situation where it's possible to actually use Let's Encrypt to do the work and to get you the certificates, it will save you a lot of time.
Yep. And so something else I want to mention, because it reminded me of this. So basically, again, we have several different files, usually, not always, depending on the format. It could be like a CA file, a key file, and a cert file, and then your app will have a place to put them. So it'll ask you for, the private key, it'll ask you for the certificate file, and you just do what it says. Or it could be like a full chain that has everything in one file. Now, what I've experienced in my career quite often is you'll have the documentation for the app say something like, we support the full chain, or we also support you putting in the individual files. You could put in the full chain, or you could just put them individually. But what we prefer that you use the full chain. Now, when it says that, like an app or a company says they prefer the full chain, do it. It's not a preference. There's a reason why they went out of their way to say they prefer this. And I feel like they should change the verbiage sometimes, because you'll have a situation, I think it might have been the same that you're talking about, where it passes your checks. And one of the things I do, for example, in Firefox, when I update, I always use Firefox for this because I feel like the way that they present the cert is great. When you update an app, the certificate, you click on the padlock and then click more information. You'll see the expiration date, the certificate authority, everything right there, the first thing that comes up. So it's not that you can't do this in other browsers. You can. It's just that Firefox, I just personally like the way that it presents the information. So even if I'm not using Firefox, I'll use it for that. Now, and then it looks good, right? So you put the individual files in there. Firefox says that the certificate expires next year. It's a valid cert and it's happy. Okay, fine. Then you get people calling in. Well, why is it not good? It's telling me that the cert can't be trusted. Probably because the documentation mentioned that they prefer the full chain, and depending on the browser, they might behave differently. So no one on the software vendor side of things is ever going to put, we recommend something, unless they've run into something that was broken, and that's what made them put that in the documentation. So even though the verbiage is making it out to be like, the full chain is preferred, but we support the other methods, okay, there's a red flag there. There's a reason why they went out to call out the full chain, use the full chain, because you will be preventing those weird calls like, people are calling in saying the cert is invalid, but when I check it, it's fine. So what's going on here? Well, they're using a different browser or something else, and it's not being presented the way the browser wants it. Just do what the documentation said is the preferred practice, and you'll save yourself some tech support calls, I can almost promise you.
Yeah, and there are online validators for this. There are tools online that you can use to check this. Even OpenSSL, you can use that directly on the command line to test the website to see if everything is properly configured or not, and it will tell you, and it will provide you a verbose output of what's wrong there, if anything is. It's a really good tool. It's also how you generate the certificate request, by the way. If you want to create a certificate request, the command line is pretty easy. You can look that up pretty quickly. It's with OpenSSL executable that you can do that. And and sometimes, getting back to the point of it failing on some browsers, sometimes it works on the desktop versions of the browsers and it will fail on mobile. Chrome or Firefox or whatever, it will fail on the mobile version, where on the desktop one it will say that everything is fine. So the testing has to be extensive when you're just starting to deploy the service. On subsequent updates to the certificate, it's not that much of a deal because you already found the issues that may arise. But the first time that you're deploying a service or a website that needs a certificate, do test it on as much broad testing suite as you can. Sometimes it will fail on mobile.
Yep. Now, I think the only other topic on my end about this that I want to bring up, and I think I'd be remiss if I didn't start talking about this, Let's Encrypt. We've mentioned it a few times. And for anyone who doesn't know, Let's Encrypt is one of my favorite things because it's really made the whole process more approachable for many people because it really automates a lot of this. There are some issues with Let's Encrypt because nothing is perfect, and there's some, situations where it might not be the best fit. But I also think there's some stigma around Let's Encrypt because they give you free certs. That's what it does. You install a tool called CertBot, and you still have to prove that you own the domain, but it's automated. The renewal process is automated, and the difference here is that the certs will expire every 3 months rather than a year if you were to purchase one. But there really isn't any excuse, in my opinion, anymore to not encrypt something. I would hear the argument, well, I don't care about my blog. I don't have personally identifiable information there. I'm not taking credit cards. I'm not selling anything. The only person who logs in is me. I don't even let people do that. So I'm just not going to secure it. Well, the problem is nowadays, whether you like it or not, your browser's going to yell at the user if they're trying to visit your blog if it's not encrypted. But then also getting back to Let's Encrypt, now we have someone who might not be an IT person. They just have a blog. Maybe that's as far as they go into IT. Now they can actually have a certificate and they have an easy interface through which to get one. So Let's Encrypt is great. And I use it a lot. Now there's some situations where it doesn't work as well as it could because there's some warts, basically, one of which is the domain validation process, which can work very well or very not well, depending on the situation. For example, if you look at the CertBot documentation, they have a list of, I don't know how many services that they support, meaning if you were to purchase your domain through one of those services, and these are third-party services not really related to Let's Encrypt, but Let's Encrypt has some kind of a way to validate through that service, then there's a way to do it. I think Amazon Web Services might be one, I'm pretty sure, if I'm not mistaken. Anyway, whatever it is, it hooks into that, and it automatically validates your domain, and you're good. Otherwise, the side effect of this is that you could have an internal app that you might let people access through VPN, for example, but you want it to be secure with that padlock. But guess what? If it doesn't have open access to the internet, it can't validate anything because it's not going to have an open connection for Let's Encrypt to come back, because the request goes out and then it comes back. And if it can't come back because you're under, it's protected by VPN or whatever, then it can't validate the domain. You have to do that manually. Or you could use one of those validation services that Let's Encrypt hooks into that'll validate it for you. That's great. But if you get your domain through a company, or you don't have one of those company, any of them on the list, you don't have an account there, then it can't do it. So I've literally seen people for a minute, they open up the firewall to let Let's Encrypt out and come back, then they close it again. because it needs that communication out and in. And they'll find themselves doing this every 3 months because, well, it expires every 3 months. So they have like an Outlook reminder. It comes up. It's time to do the Let's Encrypt dance where they just open the firewall. It's a terrible way to do it, but some people do this. So I'm just, as much as I love Let's Encrypt, I'm just trying to be unbiased here and kind of let people know what some of the issues are. Another issue I've run into is that you could have this application that is a very old version, but it's still being patched. It could be like a long-term support release of an application that just so happens to have been created before Let's Encrypt itself was created. So it doesn't recognize Let's Encrypt as a certificate provider, even though they are a legitimate certificate provider, and you can't use them because you're using this still supported but older version of the app. Maybe you're patching it regularly, and the certificates, I don't know, for some reason, just the inside the app itself doesn't recognize Let's Encrypt. Well, unfortunately, even if you don't normally buy a cert, you're going to have to, or update to a newer version. So there's some side effects here, but Let's Encrypt is very easy to use. I think every cloud provider out there has a write-up on how to secure something with Let's Encrypt. So it's very approachable. So yeah, I mean, those are some thoughts about Let's Encrypt. Maybe we'll talk more about it in another episode, but that's just kind of like a high level of what it does.
Yeah, and that's also a good way to close the episode. We're running long already.
Yeah.
But you just stress out the point that you made. You really should be using encryption and by extension certificates on basically any service that you have. Running it unencrypted is no longer an option today.
Right. It is not an option. And we'll be talking about more of these concepts going forward. You could think of this episode as the precursor to many that'll branch from this episode. We will have to get the initial understanding out there, so we have something to refer people back to. And then we'll be building on these individual technologies later on whenever we have a slower news period, if it happens.
If it happens.
Right. So there you go. That was our episode for this week. This was a lot of fun. I think this is going to help a lot of people out there that might not already be knowledgeable on this subject. And if nothing else, maybe you guys learned a best practice or two. I shouldn't say that word again, but if nothing else, if you've learned nothing else, hopefully you already knew, or you have learned not to email the private key, the certificate file to anyone.
That's something.
That is something. All right.
Okay, everybody. See you on the next one.
Thank you.
Bye.